All right, welcome back, Algebra. I am super excited about this lesson, so let's get going. Today we're going to be talking about permutations and combinations, and I'll get to those words in a second, kind of as we get through the lesson. But first of all, just know this. In a permutation, order matters, and in a combination, order does not matter. Okay, so let's look at this first question. A designer has 7 different paintings that need to be placed in a home. How many ways can they arrange those paintings? So let's say that we have 7 different rooms for these 7 different paintings. Okay, so we've got 7 different rooms. Now, we're in the first room. So I walk into that first room. How many different paintings could I choose from to put there? Well, I have got 7 different paintings that I could put up, so there's 7 different options. So I pick one, put it in that room, we move to the next room. Now in that next room, how many paintings do I have to choose from in that room? You might be tempted to say 7, but it's not 7 anymore, because remember, I put one of those paintings in the first room already. So how many paintings do I have for the second room? Well, I have 6 left, so I would be able to choose from 6 paintings. Okay, now let's walk into the third room. So I put one in the first room, one in the second room. Now I'm in the third room. How many paintings do I have left? Well, I've got 5, so there's 5 different ones that I have to choose from. I walk into the next room. I put 1, 2, 3 up already, so that means I have 4 left. And then the next room, I have 3 choices for the next one. And then in room number 6, I've only got 2 choices. And when I make it to the last room, I've only got 1 painting left, so I only have 1 choice. So do you see how the further we get into this process, the less we have to choose? After we choose 1, now we only have 6 left to choose from. Then we choose another one, now we've only got 5 left to choose from. So you see what's happening. Now, if I want to know how many total ways that we could do this, here's all I need to do. I need to multiply these together. I need to multiply 7 times 6 times 5 times 4 times 3 times 2 times 1. All right? Now, you can put all of these in your calculator. Let me show you. This is just kind of bonus learning for today. On your calculator, you should see an exclamation point. All right? What I have written there is read 7 factorial. Okay, 7 exclamation point means 7 factorial. And 7 factorial just means 7 times 6 times 5 times 4 times 3 times 2 times 1. So let's see what that is. How many different ways could this happen? So 7 factorial is going to be 5,040. 5,040. Wow, that's a lot of different ways that we could arrange these paintings. Now let me ask you a question. Does the order matter for these paintings? Okay, does the order matter? Well, yeah, it does. Because if you put a picture of a mountain in one room and a picture of a beach in another room, that would definitely be different than if there was a beach in that first room and a mountain in the second room. So order here that we chose them absolutely does matter. And this is an example of a permutation. Okay, because order matters in this case. Let's look at another one. There's 25 students in a class who need to do a presentation. How many ways can the teacher select who goes first and second and third? Okay, so the teacher's going to make 3 selections, first, second, and third. How many options are there for the teacher to choose from who goes first? Well, there's 25 students, so there's 25 people who could go first. Okay, so the teacher's made a choice on who goes first. I don't know who it is, but they've chosen somebody. Now they need to choose who goes second. How many students are left to choose from to go second? Well, we started with 25, but we already chose one to go first. I don't know who it was, but it was somebody. So that means we only have 24 students left to go second. Okay, now, how about the third? So we've already chose somebody to go first. We've chose somebody else to go second. So we've chosen 2 students already. That means there's only 23 students left who we could choose to go third. So let's multiply these together and see how many different ways out of this class of 25 students could the teacher choose who goes first and second and third. 25 times 24 times 23 is 13,800. Wow, 13,800 different ways that this could go. So the point of this lesson is be nice to your teachers because we've got a lot of decisions to make, a lot of stuff going on. 13,800 different ways that we could select from a class of 25, just who's going first and second or third. Now, I got a question. In this problem, does order matter? Yeah, it sure does. I mean, it's different if you present first or you present third. That's going to be different, right? And so order does matter. So this is another permutation, okay? Ooh, let's look at this one. This time I'm just going to tweak slightly the last problem that we did. There's 25 students in a class who need to do a presentation. The teacher wants 3 students to present on the first day. How many ways can this happen? Okay, so first of all, let me do this wrong. How many options are there for who goes first? Well, there's 25 options for first. How many are there for second? Well, we just did this, 24 and 23. Now, let me ask you a question. I'm not selecting at this point who goes first, second, and third. I'm just selecting, I'm going to choose 3 students to go on that first day. Maybe they're going first, maybe they're going third, but for the sake of this problem, it doesn't matter. It's just 3 students who are going on the first day. Now, there's a pretty complicated formula. Since the order doesn't matter in which order I choose them, I could choose Billy and then Jamie and then Johnny, right? And they're my first 3, and they're going on the first day. But it doesn't matter if I select Billy, Jamie, Johnny, or if I would say Johnny, Jamie, Billy, you guys are going on the first day. All 3 of them are still going on the first day. So it doesn't matter what order I said their names in, they're still going on the first day. So if order does not matter, this is a combination. And combinations are a little bit more tricky to figure out. All right, so let's talk about this formula that I have up here. First of all, n is the number of students that there are, the number of choices that we have. So this is going to be, we'll put 25 in for n, and r is the number that we're actually choosing. So we're choosing 3 students, so wherever there's an r, we're going to put a 3. And we'll go n is 25 minus 3 factorial. Okay. Going to be easy, no sweat. Let's just put this into our calculators. 25 factorial over 3 factorial times 25 minus 3 factorial. And when we do this, my calculator gave me an error. Now let's get it. There we go. 2,300 different ways. Wow. That was very similar to the last problem we had, but last problem it was 13,800 when order mattered. Now when order doesn't matter, we're all the way down to only 2,300 different ways that we could do this. Now, I bet you're wondering, am I going to have to memorize that? No, actually you're not. You're not going to have to memorize this formula at all because with your calculator, you've got a really, really cool key that's actually going to figure this out for you, all right? It's going to figure it out for you. Your key that you're going to use is going to look something like this. Since this is a combination, you're going to look for a C, and it's going to be an N, and then my calculator has a big C and a little r. So here's what I want you to do. If you've got your calculator, pull it out, and I want you to find that key and then punch these into your calculator, okay? So here's how my calculator will work. The first thing that I have to do is I have to put in 25 because there's 25 different people that I could choose from, okay? 25 for this choice. Order doesn't matter, so this is a combination. So now I have to hit my C button, okay? Or my one that's looking like that. So I put in 25 first, and that's going in for my N, because there's 25 that I could choose. It's a combination, so order doesn't matter, so then I hit the combination, and then I need to put in my R, and I'm choosing 3 people. So I put in 3, and I get the exact same number, 2,300. So if you have your calculator, you actually don't even need to use this formula. You can just use it, because it's already figured out for you, so you might as well do it. Let's go back and let's tweak this first one. A gallery has 7 different paintings. A homeowner is going to choose 4 paintings to place in their house. How many combinations of paintings are possible? So the homeowner is going to the gallery and they're just going to pick 4 paintings. Now I've got a question. If they're picking paintings to buy, does it matter which one they say, I want this one, I want this one, and then this one and this one, or they do it in a different order, but they choose the same one, I want that one, and that one. Order doesn't matter when you're selecting them to take home. So it doesn't matter. This is a combination. So let's use this. So there are 7 paintings, and we are going to choose 4 of them. Okay, so 7 paintings, and we'll choose 4 of them. And since order doesn't matter, the order that we pick them doesn't matter, this is going to be a combination. All right, so let's put this into our calculator and see what we get. 7 paintings. I'm going to choose 4 of them, 35 different ways. 35 different ways I can select those paintings. So I know this isn't the easiest lesson in the world, but I also know that you can do it. All right, so get after it and good luck.